On page 40, this type of a trig problem actually has two triangles kind of overlapping one another, and we call them double trig problems sometimes. There is another way to solve them that you'll learn later on, but you can solve them using SOHCAHTOA, just based what you already know. There's a way to do that. So the best way I think to explain this to start off is to use patty paper to understand what how you could solve what they're asking for. Let's read the problem. You have a flagpole at the top of a building. Okay, you see that sticking off the top of the building. 300 feet from the base of the building, so 300 feet out, the angle of elevation all the way up to the pole is 32 degrees. So that is 32 all the way up. The angle of elevation to the bottom of the pole is only 30 degrees. There's a 2-degree difference there. If you look only 30 degrees, you hit the bottom of the pole. If you look up 32 degrees, you hit the top of the pole. Determine the length of the flagpole. You're looking for the length of the flagpole. So in this problem here, the flagpole is what you're looking for. The problem with the flagpole is that it is the side of a triangle that doesn't have a right angle. There's no right angles in that triangle. And based on what you know now, you can only do right triangle trigonometry. So you can't immediately find that and say that that's a 2-degree angle and use any sort of SOHCAHTOA, because that is not part of a right triangle. So what I think you should do is take your patty paper and put it over the picture. And I want you to trace the big triangle first, just like this. And we're going to try to find this right here. We're going to try to find the length or the height from the bottom of the building all the way to the top of the flagpole, that entire top or that entire side. And we know that this is 300, so right on my patty paper I'm going to write 300. I want to find how big this is, so x. And I know that this angle, this entire angle, all of it is 32 degrees. So now I'm just going to take this piece of patty paper and move it over for a minute. You could solve that because you have, from 32 degrees, you have opposite and adjacent, so that's a tangent problem. But you either can use a different piece of the same patty paper, a different section, or maybe even an entirely new piece, which is fine. And then you're going to retrace the smaller triangle to the bottom of the flagpole. And when you do that, you're going to try to find the height of the building. You know that this angle in this corner is only 30 degrees, and this is still 300. That didn't change from there to there. So when I take this piece of patty paper and I put it on top of this one, the length of the flagpole is the difference in the two heights. If I wanted to find out the flagpole, I would figure out how long this is and subtract how long this is, and that'll leave me with the length of the flagpole. So on this problem, I would do tangent of 32 equals x over 300. That will tell me the biggest height from the bottom of the building all the way to the top of the flagpole. And you'll write that number down, whatever you get. And then on the smaller triangle, it's going to be tangent again, tangent, but of this time it's 30 degrees, it's the smaller angle. So tangent of 30 equals x over 300. You'll solve for x there, and whatever you get will be the height of the building. And then you subtract this answer minus this answer, and the difference should be the height of just the flagpole, because the flagpole is this part sticking up right there. The problem below it with the boat and the cliff and the lighthouse is really the same problem, just with different context. The flagpole in the first problem is very similar to the lighthouse here. It's the part that sticks up. So you're going to do the same thing with different pieces of patty paper on this one. You have the bigger triangle with the entire height and an angle of 21. Then you're going to in a bottom of 300. And then you have the smaller triangle with an angle of 18, the bottom of 300. And you're trying to find the difference between that height of the big triangle and that height of the small triangle. And the answer is how big the lighthouse is. So do it the same way we did the one above.